Okay, so today we're going to talk about circles and lengths of segments. So that's our objective, is to understand theorems. Understand theorems about circles and lengths of segments. And this comes out of lesson 9-7. So you can read through there. So first off, I need you to understand what I'm talking about when we refer to lengths of segments. It's a vocab. In fact, it should be the last vocab word for the chapter. And what they're talking about, the segment, it's the segment of a chord. And the segment of a chord is simply the length of one part of a chord. So there's got to be some sort of intersection happening so that there's a definite endpoint for our segment. So let me give you an example. Kind of looks like what we were talking about with the two chords intersecting. And we can figure out the measure of the angle. So we've got chord AB, we've got chord CD. We've got this is circle O, and the intersection is point P. So we would say that segment AP and segment PB are segments of chord AB. And just like we could say that segment CP and segment PD are segments of chord CD. So they're just parts of a segment, part of a chord, but because there's an intersection, there is definite beginning and an end of each of the segments. So understanding what a segment of a chord is now allows us to go to the next level, which is Theorem 9-11. So hold on here for a minute. Okay, so Theorem 9-11. Says when two chords intersect inside a circle, the product of the segments of one chord equals the product of the segments of the other chord. So let's draw a picture of this so you can visualize what I'm talking about. So here's AB, here's CD. We'll call this point P. And again, P is not the same as the center of the circle. We'll call that U over here. So what this is saying is that if I take the segments of one chord and multiply them together, so if I take segment, the length of AP, and I multiply it by the length of PB, I am going to get exactly the same product from the segments multiplied of the other chord. So that means the length of CP times the length of PD. That's what this theorem tells me. And how they go about coming up with this answer is you can get some angles that are congruent to each other. If we draw some auxiliary lines, you then can get triangles similar. So the auxiliary lines would get drawn here. And here. And because we have two angles that intercept the same arc, so angle out of A cuts off BD and out of C cuts off BD, we can get this angle congruent to this angle. And then we've got the reverse going the other direction, where the angle coming out of D cuts off the arc AC, and the angle coming out of B also cuts off the same. So we can get those two that are going to be congruent. So through angle-angle similarity postulate, we can get those two triangles similar to each other, so then we can get their corresponding sides are going to be in proportion, and then we would do cross products and get our answer here. So that's how they go about doing that one. So that's one thing you get to work on tonight. Here's another one. Next theorem. This is theorem 912. And this one says when two secant segments are drawn to a circle, from an external point, the product of one secant segment and its external segment equals the product of the other secant segment and its external segment. So here's what's strange about all of these theorems in this chapter. Sometimes we add things together, sometimes we subtract things, sometimes we cut things in half, sometimes they're exactly the same, sometimes we multiply things. So that's why you guys are pretty lucky that I'm letting you use your theorem cards on your quizzes and tests. But note, at the end of chapter 9 is where this stops. And starting with chapter, a teeny bit from 10, mainly chapter 11 on, no more theorem cards. Because all the theorem cards pretty much are formulas, and you're going to have to commit them to memory. Okay? So let's draw a picture of this one to understand what they're talking about. So we've got a circle, and we've got two secants. And remember, secants contain a chord of inside the circle. So we'll call this part AB. We'll call this part CD. And we'll call this point X. So what it says is that the product of one secant segment, so that one secant segment goes from the outside all the way across. So that would be the XA. We're going to multiply by the external segment of that secant. That's the part that's outside the circle. So that would be XB. That product is going to be the same as the product of the other secant, that's the XC, times its external segment, that would be the XD. Okay? So again, I'll highlight over here, these are called external segments. So that's his, okay? Then we got one more theorem for you, slight variation of this one. What if it's not two secants? What do we do then? So this is the last theorem, theorem 913. And it says when a secant segment and a tangent segment are drawn to a circle from an external point the product of the secant segment and its external segment, so it starts off like 9/12, is equal to the square of the tangent segment. So when a secant segment and a tangent segment are drawn to a circle from an external point, the product of the secant segment and its external segment, which sounds just like what the last one said, is going to be equal to the square of the tangent segment. Actually, let me shorten this a little bit. Now notice it says tangent segment. It doesn't say tangent. So it's a segment that is tangent to the circle. So that's its point of tangency. So we'll call this point P, we'll call this A, we'll call this B, and we'll call this C. So what this says is the length of PA, that's the entire secant, times its external segment, which is the PB, is going to be equal to the tangent segment squared. Now, honestly, this is the same as Theorem 9/12. The tangent is the entire thing from PC. Its external segment is PC. That's why we multiply it by itself, because not only is it the segment, it's also the external segment, because there's nothing inside. So it's basically a slight variation of 9/12. Okay? All right, so the deal is you're going to have all these drawings, and you're going to have to figure out, okay, which theorem am I going to use on this one? We have so many different ideas now on how to solve problems. That's why it's really important for you guys to go through those theorem cards to make sure that you understand them. So that's what you're going to be working on tonight on page 364, 365.